I'm delighted to introduce Jon Bennie, who's going to give our SI Challenge of the Month today. So Jon and I actually go way back. We did our postdocs together at the same time when the SI was really just a twinkle in people's eyes. And it's probably fair to say Jon invented the microclimate models upon which I built my whole career, which I think is a reasonable way of starting an introduction. We were working on sort of climate change things at that time, and then which actually sort of a thread he's going to pick up in the session today. But he went from there to go and do a postdoc with Kevin Gaston on artificial light at night and the ecological impacts of that before getting a lectureship in the geography department, lectureship in biogeography, which it's probably fair to say it was just a way of being able to do ecology in a geography department. But I think in many ways also actually allowed you to sort of foster that interdisciplinary working that, you know, departments are really good at. You've got physical and natural geographers. And you obviously did really well in that kind of strand of work, because now you're an associate professor in biogeography. And without further ado, I'll hand over to you for what I'm sure will be a really interesting talk. Thank you.
Thanks, Ilya. Thanks. Thank you for asking me to talk today. The kind of challenge I'm going to be talking about today is how we think about and how we do conservation in an era when climate is changing very rapidly. And it's going to be a bit of a talk of two halves. The first half, I'm going to be very much within my comfort zone, talking about the research that I've been involved in ecology, biogeography, and where my background is, and thinking about climate change affects the distribution and ranges of different plants and animals. And then I'm going to be talking about some work that I've been doing a little bit more recently with Caitlin and the Adaptive Heritage Practice Lab, looking at how we essentially thinking about how we can adapt the way that we think about conservation, given that the world is rapidly changing. And conservation by its very nature is kind of almost by definition trying to preserve things as they were. That's in the kind of deep past or the more recent cultural landscapes. And we're going to be thinking about whether that's, on the one hand, what we might want to be doing in the future, but also whether it's going to be possible. And if not, are there alternatives that we can still find value in the natural world in the future? So, yeah. So I'm not going to talk too much about COP30, but I should, if we're talking about climate change, it would probably be a bit of a miss not to acknowledge that we are coming to the end of the 30th Conference of the Parties, the 30th big United Nations climate change conference. And we, at this stage, are, I mean, there hasn't been a huge amount of progress. You can be a glass half empty or glass half full, I think, with these conferences. But it's fairly clear that we are, at least at the moment, on track to exceed the aim of the Paris Agreement for 1.5 degrees global warming, probably to exceed the target of 2 degrees, maybe in the region of about 2.6 or so degrees. Now, it's nice to see some undergraduates in the audience, because I was thinking about this earlier, and I was thinking about when I was an undergraduate, and this makes me feel really old. But I was an undergraduate, not quite in 1990, but 1992, but in COP1. So we're now in COP30, which was in 1995. I was in my first year studying geography. And it was quite an exciting time to be kind of involved in this kind of thing, because for over a century, scientists have been kind of aware of the greenhouse effect and have been talking about climate change and global warming, anthropogenic climate change. The environmental movement that kind of picked up on that in the late 20th century, and we're like Greenpeace and Friends of the Earth, we're talking about climate change, but it was really only in the 90s that this started getting policy attention, particularly in 1990 and 1992 with the Intergovernmental Panel on Climate Change first reports, and then in 1995 with the first annual conference, UN Conference on Climate Change Conference of Parties. And I look back at 1990, 1992 to see what it said about the natural world and ecosystems, species, and the kind of things that I'm kind of interested in terms of nature conservation. And the main from the summary from policymakers, we say it says that species respond differently to climate change. Some will increase, others will decrease. Ecosystems will change. Some species may be displaced at high latitudes and altitudes and may be prone to local and possible global extinction. Other species may thrive. So it's pretty much sitting on the fence there. Things might be good for some species, things might be bad for some species. Species might shift north to higher elevation. So there was quite a big drive, I think, at this point to start actually getting some little bit more certainty about what might be the consequences for the natural world. And then around about the turn of this century, again, this is making me feel really old, I started my PhD up in Durham with Brian Huntley, and I was working in a paleoecology lab, essentially with Brian Huntley. He's a paleoecologist, and some of the things they were working on, paleoecologists, over you who might not be aware, paleoecologists look at plant and animal remains from the past and try to often reconstruct past climates. And classic example is this really nice little species here, mountain avens or Dryas octopetala. It's a really cute little plant, if you like small plants, which I do. It's got little leaves which look almost like oak leaves. It's got these fantastic 8-petaled flowers, hence octopetala. It produces a lot of pollen, and it's really important. Two things are really important I think you have to know about it. It produces a lot of pollen, and it's a specialist of tundra and high altitude alpine kind of environments. And today, if you want to see mountain avens, you've got to go. You can find it in the Highlands of Scotland at high altitude. You can find it in Scandinavia, and it's got circumpolar distribution. So it goes all the way around northern Russia, Kamchatka, Alaska, all the way around the northern hemisphere. But it's a really good indicator of tundra conditions. And in fact, it's such a good indicator that that if you look at pollen cores going down, look back in time through different strata, extract the pollen. In Scandinavia, people at quite an early date noticed that there was a lot of Dryas pollen in the lower parts of those cores. Then there was a gap, and then there was another chunk of Dryas pollen, and that younger Dryas pollen got called the younger Dryas, and that gave the name to a cooling period after the last glacial maximum. So you can see here the pink line here is temperature from Greenland ice core. So this isn't from the pollen diagram, but we now have this warming. So temperatures after the last glacial, about 14,000 years ago, almost got to their current levels, and then suddenly it got colder again. And we knew that originally. We discovered that by the pollen in these plants. So that's what paleoecologists do. They look at pollen. Apologies to any paleoecologists who might be listening. There are a lot more exciting things than that, but that's essentially the idea. So the idea is if we know where plants grow currently, and we know where they were in the past, we can make inferences about what the climate was like in different places in the past. And what was kind of exciting when I was working in Durham was the research group there was trying to flip that on its head and say, well, increasingly, we've got predictions, global climate models of what the climate's going to be like in the future. And if we know where plants are growing currently, and we know what the climate's like currently, then we can predict where plants are going to be in the future. And so this led to kind of climate envelope modeling, which Brian, I was working with, was quite one of the kind of people who was really pushing this forward. And I'll give you just an example. This is from a 1995 paper, so really old. Well, not quite as old as me, but pretty old. And it's looking at Cornish heath. So this is a species that will be familiar to anybody who's been to Goonhilly Downs and the lizard. Sorry about the quality. These are figures from 1995, but the top one is its current distribution. And it's pretty much northern Spain, Atlantic coast of France, and you can't see, but there's one little dot on the Lizard Peninsula, which is why it's called, we call it Cornish heath, even though it's actually northern Spain. It's got a Lusitanian distribution, which is what we call this kind of Atlantic distribution. The right-hand side top is a prediction of that distribution just using climate data. So you can see we can explain where it is pretty well using climate data. And the bottom two are two different climate models based on doubling of CO2. So doubling from pre-industrial levels about 280 parts per million in the atmosphere. So this will be up to about 560 if you let the climate equilibrate about 560, and you predict where Cornish heath should be. Put that into context, 270 is pre-industrial, 560 is this, we're by now about 420. So we're getting there. And you can see that one of these climate models is saying, well, it should be pretty abundant in southern Greenland Island, but pretty much absent about from the core of its range now. Slightly more extreme climate model says the only places that it should be growing are the Highlands of Scotland and Poland and central Scandinavia. So these kind of models were really influential to kind of like sort of making us realize that even 2 degrees kinds of climate change projections that are being put forward could potentially lead to really large potential shifts in where plants and animals can survive, can live. And of course, the question is, if we're going from a species that's in northern Spain and the Lizard Peninsula and is in the future going to be living in Poland, is how is it going to get there? Can it disperse? Some species might be able to disperse, might be able to track climate change, but many won't be able to. So about the same time as people were doing these kind of models, and there was a massive explosion of this. I kind of brought along this book because I picked it up off the shelf. This is the Climatic Risk Atlas of European Butterflies, which was again early 2000s. It's got pages and pages of these predictions of different climate models where butterfly species will be tracking and trying to think which butterfly species are at risk due to climate change, which are at risk of extinction. And there are some really influential papers thinking about modelling, but also looking at the empirical evidence for shifts so far. So Parmesan and Ewer in 2003 did a big meta-analysis and it concluded that actually most species that have shifted their ranges have done in the same direction as the models are predicting. So there's some evidence there. Species were shifting at about 6.1 kilometres. And phenology in spring, things were advancing earlier. And Chris Thomas at York and his co-authors did a really influential paper where they used a whole suite of regions and different types of different groups of species and looked kind of globally, tried to extend that with a bit of ecological theory called species area curves. And they concluded that by 2050, between 15 and 37% of species globally will be committed to extinction. I think the one thing we should say here is committed to extinction doesn't necessarily mean they'll be extinct by 2050. They're expecting to have lags in there, but the climate will have shifted so much that their populations will no longer be much. So that's a real acceleration. I mean, we're living through a biodiversity crisis at the moment with various land pressures, land use change, habitat destruction, resource extraction, but we're kind of accelerating that if we believe these predictions. And Ilya and Rob Wilson in 2011 did a really nice analysis, again looking at empirical evidence of these shifts, and actually came up with broadly same kind of prediction. So this is looking at species trends and saying and using kind of statistical methods to try and predict how many species are likely to go extinct in this kind of timescale. And so empirical evidence gave a probability of about 14%. But we're looking at something in that magnitude. So I wanted to kind of, these kind of shifts were predicted at the turn of the century. Quite often they use 2050 as their kind of target year, which in the early 2000s seemed impossibly far off in the future. We're now pretty much halfway there. So it's kind of a good time to start thinking about why these changes happening. Is there still evidence for them? And one of the things I did during my PhD, I was kind of lucky to have access to a data set from the 1950s collected by a botanist called Frank Perrin, who wrote the Atlas Flora, the Atlas of the Flora of the British Isles. He's a really famous botanist. And I met him in his house in Cambridgeshire, and he went up to his attic and he came down with a dusty box full of, it's a card, which this is a photocopy. This, for the younger people amongst you, is what databases used to look like in the 1950s. It's a punched hole card. Basically, the way you extract your data is you stick a knitting needle through a hole that says Dorset, and you pull it up, and all the records from Dorset lift out of the box, and all the other ones stay in there. So I spent a big chunk of my PhD transcribing some of those. I also spent a big chunk of my PhD going with his old 1950s ordnance survey maps and refinding the plots where he'd done that, and then going and surveying. Good. Well, a bit of advice: don't ever throw away any of your data. This all went into my PhD, published bits of it, but it's just been involved in a really, I think, really exciting multi-author paper. He's one of the authors, but this is currently in press. We've got sites all the way across Europe, grassland, forest, and mountain sites, and we're basically looking for evidence of what they call thermophilization. So if species are shifting their ranges, we'd expect, if you monitor a plot over decades, you'd expect the species from warmer areas to increase, and the species from cooler areas to either disappear or shift further north. And we do find evidence for that in this paper, but it is kind of complicated, as it usually is. So this top one is the rate of thermophilization, and the centre bit is basically overall what's happening. So you can see the mountain, if that dot is above the line, you're getting plant communities that are representative of warmer areas. So in the mountains, you're definitely getting that. So if you go to a place in the mountains, there are warmth-loving species there that weren't there decades ago. But that's being driven by decline of cold adapted species. It's being driven by extinctions rather than species moving up slow. We're not too sure why that is, but it looks like the mechanism there is we're getting species extinction, but not getting new warmth-loving species necessarily coming in at the same rate. If you look at forests, we're getting cold adapted species going extinct, warmth adapted species moving in. And if you look at the grassland plots like mine, you're getting warmth adapted species coming in, but actually you're not losing those cold adapted species. So there's a lot of, I can talk about, I haven't got time to go into the details of why we think that might be, but there are a lot of different reasons for that. But the kind of key point here is that there's probably across these systems, there's a climatic debt. So there's a lag. So things aren't in equilibrium with climate. So the climate is warming, but species that probably will go extinct have not yet gone extinct. The species that probably will arrive have not yet arrived. So we're out of equilibrium with climate already, even with the past few decades of climate warming. This kind of links with some stuff that I did with Brian Huntley and also Andrew Sluggett, who used to be at this within the ESI, thinking about Caledonian pine forests, and we did some modelling of forest dynamics, and we looked at where Scots pine, which is a kind of classic Scottish Caledonian pine forest species. It's really important for a whole range of wildlife like capercaillie, Scottish crossbill, pine martens, wildcats. this habitat is really important. This habitat is a kind of outlier of the boreal forests that cover much of the northern hemisphere. It's unusual for the British Isles. It's really just typical of the Scottish Highlands. And then we looked at oak, the suitability of oak, which is a much more common in the rest of the British Isles, and it tends to be a kind of Atlantic, kind of temperate rainforest species, if you like. And we looked at two different time periods. So this isn't going in the future. This is looking at that period which we call the Little Ice Age, so relatively recent, 1786 to 1815. The climatic records from that period. We try to downscale them across the landscape and then grow the sort of virtual forest and see what happens. And what we find is that this area here, which is a special area of conservation specifically for Caledonian pine forests, is under the current climate actually not particularly well suited Caledonian pine forests. Those pine forests are probably there as a relic of past climates. What may well be more suited is oak, so this bottom two are oak under different time periods, and the pine should currently be higher up in the mountains, higher elevation. So this kind of thing causes problems for conservation managers, because if you're thinking about managing this patch here, for anybody who knows it, it's the Blackwood and Rannoch, so it's a National Nature Reserve, a special area of conservation. It's a really important conservation site. But in the long term, maybe it's just not suitable for the reasons for which it was founded, and maybe we should be thinking about establishing pine forests at higher elevations. So those move about the landscape. And this is not thinking about future climate change. This is just the level of climate change we've had since the late 18th, early 19th century. So I wanted to talk a little bit about how the dynamics of species change happen at kind of maybe at a slightly smaller scale. And so one of the systems I've worked on quite a lot is this little butterfly on the left-hand side. It's called the silver-spotted skipper. It's a really sweet little thing. It's not the flashiest of butterflies, but it's a really nice little thing. It's got these little silver spots on the bottom of the wing. And it's this species, it was restricted in the early 80s. There were a handful of sites, maybe 3 or 4 sites in the southeast of England. And part of the reason why it's hanging on, it's at its edge of its range in southeast England, is because female silver-spotted skippers only lay their eggs, and those are their eggs in the middle, little white blobs on a thin, short fescue grass. Only lay their eggs at temperatures above about 23 degrees. Butterfly flies, flight season is a couple of weeks in August, so it needs quite high temperatures. And so it's a thermal image there where we've looked at site selection at quite a fine scale where these butterflies can lay their eggs. So they tended, or historically, they tended to be limited to steep south-facing slopes. They get a lot of sunshine, really heat up in the sun. And this is reflected in their population dynamics. So these two lines here, the orange line is the July-August mean maximum temperature. July-August mean daily temperature. Mean daily temperature maximum. So the average high temperature during the July and August, if that makes sense. And the blue line is a change in the National Population Index, butterfly monitoring, UK butterfly monitoring scheme. And you can see that when we get a warm summer, we get an increase in butterflies. When we get a cool summer, we get a decrease in butterflies. And this is kind of typical of these kind of range edge dynamics. We're in the cool summer. It goes much further north. It does get to southern Scandinavia. There's a subspecies which goes right up to the Arctic. But actually, in continental Scandinavia, you get pretty high summer temperatures. In southwest of England, you don't so much. So we're at this kind of cool, wet edge here. And the population dynamics are really driven by climate. So you get these increases in crashes. We've had, during the period that we've been monitoring it from 1982 to 2018, about 2 degrees of warming. What that's meant, sorry, this is some work by Zoe Davis on the egg laying rates. Yeah, so we also know the reason it has been constrained to south facing slopes is because south facing slopes can be up to 10 degrees warmer than north facing slopes once you get down to this ground level where both are named the eggs. So this is the kind of habitat. It's these kind of short graph. So we surveyed it in 1982, 1991, 2000, 2002, 2009, 2018. I say we, I only picked up on this on 2009. I wasn't around in 1982, I'm not that old. But so Chris Thomas, who's the author of the extinction paper that I mentioned earlier, did some of the first surveys, and Bob Wilson, who's from on this campus, kind of picked up on that. And then we've taken over. You can see we've got every 9 years. So if anybody has any pot of money available for funding, we're looking for excuses to go and survey it again in 2017. But we basically looked at every single habitat patch where we think it could be across the South Downs and across other places in southern England. I'm going to show you there from the South Downs. You can see we've got these kind of north-facing scarp slopes and slowly less steep insides valleys on the southern face of the South Downs, and Beachy Head down here in Eastbourne. And in 1982 in the South Downs, there were really only 2 colonies. Blue patches here are patches where we surveyed, where there's the food plant, we think it could be. And 1991 it has spread, 2000 it has gone a bit further, and it's doing this leapfrogging where it's going, you see there's a kind of isolated one on the far left there, 2002 it's started filling in, extends again, 2009, by 2018 it's pretty much up to the Arun Valley. So we'd like to go back there and kind of push this further and see it expanding. So this is a really nice example of how species are expanding, but also how that interacts with habitat fragmentation and some of the other issues, because it stalls, and in other places in the country it stalls where it's just run out of habitat, or the habitat network isn't dense enough. Other things happen at range margins as well. This is a manuscript from Charlotte, who is a PhD student who co-supervised with Robbie McDonald. And she was working on dormice, and specifically she's thinking about torpor in dormice. The dormice are called dormice from the French dormir because they sleep a lot. Actually, a lot of the time they're not sleeping. In the winter, they're hibernating. And in their active season, they go into torpor, which is still a state to hibernation. It's a temporary state. And when it's cold and wet, they basically curl up like this. These two are actually hibernating, not in torpor, strictly speaking, but they look pretty much like that. Very cute, curled up, too cold, too wet to do anything. So they lower their body temperature and just sit the day out. And she looked at national monitoring network for dormice, where people were checking dormice boxes regularly, recording their state, their condition, and whether or not they're in torpor. And one of the things she found was that in areas where there was a lot of torpor, statistically, populations were doing poorly. Makes sense, because if you're in torpor, if you're sleeping a lot during the day, you're sleeping, you're shutting yourself down during the day, you're not feeding, you're not mating, you're not reproducing, you're not doing all the things, you're not fattening yourself up for hibernation, you're not doing all the things that's important to survive and reproduce as a dormouse. So these maps here, so about the size of the text, this is going using a statistical model to predict how frequent torpor is, looking at current climate, and then using climate projections, daily climate projections from the UKCP, from the Met Office, to try and predict the number of days of torpor going forward in the future. And we're right, again, like the silver spot skipper here in the UK, we're right on the edge of hazel dormouse. So at the northwestern range, you can see they're spending about 40 to 50 days within their active season inactive. And that's probably why they're at the edge of their range there, because it's just too cold, too wet for them to to move on. As we go forward to climate projections, some of these places like North Wales, where they're really marginal at the moment, are going to be having torpor rates similar to Kent, which is kind of pretty much where they're very comfortable now. So you'd expect to see these kind of mechanisms leading to increased populations of the range margins, and in turn perhaps leading to range expansion if there's sufficient habitat for them to move. So some examples of how we kind of what we understand goes on at range margins and what is happening at the moment in shifting distributions. So I think this kind of thing is really challenging for conservation. These kind of ideas that we are committed really now to shifting species distributions. We may well be in climatic debt in terms of even what we have now. Even if we can freeze climate and prevent any further climate change, we would probably still be getting extinctions and certainly turnover. And I think that's challenging because I just pulled up a couple of examples locally of how people do conservation. Some really nice conservation organisations. Working Woodlands Cornwall works just down the road here, looking at traditional management of forests. So these are working in ancient woodlands. That's what we used to be called Atlantic oak forests. Now it tends to be called temperate rainforest, which has been quite a successful rebranding because temperate rainforest sounds much more exciting. Organisations like Thousand Year Trust or Southwest Rainforest Alliance, which are looking at not necessarily cultural management, but looking at restoring an environment that came in after the last glaciation, after that Younger Dryas, as trees first started colonising the landscape, but before humans had really heavy impact on it. So we're kind of looking back to some past state, whether it's a cultural landscape or whether it's a kind of pre-human landscape. And that tends to be what we think of. We'd like to restore native species. We like to restore cultural landscapes generally as conservationists. Well, what does that mean in a period of rapid climate change where we might not be able to go back to these states? Particularly if we're thinking about things like 1,000-year trust, thinking about 1,000-year timescales, do we know what the climate's going to be like? So recently, I've been working with Caitlin, who have set up, and Tiago's at the back there, who have set up a really, what I think is really nice way into thinking about, for me to think about some of those kind of ideas. The Adaptive Heritage Practice Lab. So we have a website, so please do come and explore it. So Caitlin, you probably all know, has worked a lot in the heritage sector, has published things like Creative Decay, and thinking about loss and change, particularly within heritage. And there's a quote there from the Apple website by Jim Perry, that heritage protection focuses on securing a stable future for the sites and landscapes that connect us to the past. So I think this is applicable both to kind of cultural heritage and to natural heritage as well. But those precious places achieved their present condition through a process of change and evolution. And there's this idea that adaptive heritage offers us to a hope in this unstable world by working to sustain value and connection as places and landscapes evolve. And I'm kind of interested in how we might do that I guess this is the crux of what I think this challenge is how do we do that in an unstable world in terms of wildlife conservation? I think probably as ecologists and people and conservation scientists, it's something that we haven't really got our heads around. We haven't really started getting our heads around. We're much more kind of embedded in defending and trying to resist change rather than think about how to manage change, how maybe to direct change. So we have a bit of a collective. I mean, I think I'm only going to talk about this for alphabetical reasons. But so far, myself, Semi Selleck in Exeter, we had a meeting last week, which was really nice to kind of start thinking about these some of these ideas and the interactions between people who are working in environmental law, culture, geography, environmental history, etc. And if you go onto the website, you can access this story map, which has a selection of places where these kind of processes are happening, where people are looking at change and or sites that are changing, that are either committed to change, or people have made a decision that they are going to have to change over time. And so a lot of these are perhaps cultural heritage sites, and imagining what that change could be, and really, I think some really imaginative ways of monitoring change. And one of the, I guess, the project that I've been involved with as part of Apple really is this contract we have with Natural England. And we were asked to develop what we called a visioning tool, which is an online kind of interface for management practitioners, people involved, stakeholders, to start thinking about how we might manage change in the landscape. And the example that Natural England gave us to look at was a plant called the dwarf pansy on the Isles of Scilly. This is the dwarf pansy. It's a really tiny little plant. You don't really get a sense of scale there. It's the flower is smaller than your fingernail. Really tiny plant. This is a bit of an unnecessary map of the UK, Britain and Irish distribution. And you can see it's only found on the Isles of Scilly and in the Channel Islands. It is found elsewhere in Europe. It's not totally endemic to these islands, but it's from a UK perspective, it's really, from a UK perspective, it's just the Isles of Scilly, British Isles, also the Channel Islands. It's very cryptic. Very few people actually go and see it. Well, people are very interested in it. People like to know that it exists, but it flowers for a week or two in May, June. It's an annual plant, so for the rest of the time, it's just a seed buried in sand dunes. So it's a kind of plant that people actually are very attached to, but don't necessarily experience it firsthand. The best place to see it, in fact, almost the only place to see it, are two sites on Scilly now. It was more widespread on Scilly. It's disappeared from a lot of sites. It's cropped up occasionally over the last 100 years or so in different places because it can remain in the seed bank. If you want to go and see it, go over to Briar in May, June, and go to Rushy Bay on the south of the island. But this is a species that's at risk of climate change, not directly due to climate, but because of sea level change. And this is a 19th century Ordnance Survey map of Rushy Bay here and Stony Port. And you see this peninsula of land here. Keep your eye on that peninsula of land, because by the mid 20th century, that's been breached and there's an island there. And if we look at more recent LiDAR data, so these are airborne LiDAR data, you can see this bit of land is retreating quite rapidly. And from the late 19th century to the last LiDAR survey, which is 2021, the coast has retreated about 80 metres. So it's really quite a lot of coastal retreat, and pretty much the only places within the UK that the dwarf pansy is are there. So you can see it's not looking good in the long term for those populations of the dwarf pansy. So how do we think about the way forward for the dwarf pansy? What do we do? There's a framework which has been quite widely adopted. Well, probably not widely adopted, but widely discussed in conservation circles, called the VAD framework. A paper by Lynch et al. A few years back kind of defined this, and it really gives us kind of three options for what we can do in conservation. these kind of changes. We can resist transformation. We can try to hold the line and stop change from happening. Stop those species coming, those populations coming extinct. We could accept transformations. We could say, okay, this is happening. How can we manage the extinction? How can we deal with extinction? Is that a thing that conservationists can do, managing extinction? Or we could direct those transformations and say, well, can we maybe think about how we can direct the direction of change can be diverted into something that's perhaps a little bit more positive. So in this kind of project, we were looking at how we might define that, the dwarf pansy. And that involved me getting out of my comfort zone and sitting down and interviewing people and trying to do social science, and not always entirely successfully, but it's a really useful, I think, practice for me. And we spoke to a lot of people who had some kind of stake in the future of this plant. And we thought about what it means, what it's meant in the past to do all of these different strategies. And the point is, we're not trying to say this is what, not going to obviously say this is what you should do. We're trying to explore what this would look like and what those future options might be and what we might be forced into doing, what we might have to accept and what we might be able to direct or resist. So one thing that came up was some years ago, there was a major storm, a series of gales that came over and entirely covered populations with sand. Will Wagstaff, who some of you work out in the other city might have come across, who used to work for the Wildlife Trust, was out there with wheelbarrows and brooms for kind of intensive management. So we might be able to maintain these areas by real intensive management of the site, going over there in a small boat with wheelbarrows and brooms, gardening, if you like. There's also a small population on Tian, another of the smaller islands, that has just appeared after a long period of intensive habitat management. Tian used to be grazed. For economic reasons, it's not economically viable to graze a small island. The vegetation's grown up. Wildlife Trust have gone and really cut it back. And so they found one lonely dwarf pansy has kind of come up due to that really intensive management. So we can try to put effort into resisting change, resisting the extinction, helping those species alive. And a lot of the time, that is what conservation does, and a lot of the time, it does feel like a losing battle with loads of people involved in it. We could, and people did in the interviews, kind of discuss this. We might actually lose it. Julian Branscombe, Wildlife Trust, said, who knows what the coast is going to behave like on 2070 from the predictions. Likelihood is Bry is going to be cut in two. We may well lose all that lower lying ground, Panson altogether. We might just lose it. And interestingly, the erosionary power flow, who is the author of the Atlas of the flora of the Isles of Scilly, but really probably knows more about the flora of Scilly than anyone else. Spoke about the extinction of shore dock, which is another annual plant on the Isles of Scilly, which is almost certainly now extinct. And she kind of said, what you do, it's a natural process. The last plant goes up to the side. And I really was, when I saw the last shore dock, we stood there, we didn't weep over it. She's a very practical woman. I can't imagine anything over it, but she did. This is kind of the kind of thing that we might see. And I thought, well, get on seed, do something, and it didn't. But it's really sad. It's a natural process. So, do we think about how we manage loss in a way that people, for example, are doing in mountain regions where they're losing glaciers? Communities are kind of marking that loss of glaciers in Switzerland, in Peru, in Iceland. There are kind of movements to kind of mark that loss. This is so Caitlin managed to get this small paper model. This is not a real dwarf pansy. It is a tiny, really intricate, beautifully made by a Falmouth art student, Wayne Parsons. So we're kind of imagining how we might memorialise this plant to the Arthur City Museum if when it goes extinct. Or do we direct? So directing might, in this context, might be things like moving the boundary of protected areas like SSI. And we spoke to people from National England, so that's really difficult legally. Boundary of the SSI is bound in legislation. We can't flexibly move it if the range of the pansy moves, and this is a mobile annual species. And it's outside the SSI, we'd have to redesignate. National England don't necessarily have the resources to do that. That's a logistical problem. Julian Branscombe said, would it make sense in 50 years' time if the site environment is going to actually look and try to recreate a population? So maybe Gwyddian towns in Cornwall. Would that population have the same value as it does on the Arthur Scilly, where it's seen as a really special local species that is endemic from a UK perspective to the Arthur Scilly? If it's on the mainland, do we care about it to the same extent? And rosemary again, said, if they really, really wanted to, they could grow it in pots, but it's not really safe. So how far do you go down the kind of idea of gardening, conservation? Which I think is kind of an interesting idea. It is, populations from Scilly are being moved to the Millennium Seed Bank in Kew. I don't know if anyone's done any, I don't think anyone's done any genetic work to see whether, for how long those populations of Scilly have been isolated and whether they're really genetically important, whether they're more recently alive or possibly so we've been thinking, I guess, about adaptive management and this idea. This is another image from this Lynch paper, which defines the RAD framework. And I guess what we might be able to do is go through this loop where we are assessing, we're reviewing our management objectives, we're implementing, we're monitoring, we're evaluating, we're adjusting our management actions, we're doing all the things that we should be doing. We don't always do very particularly well. We should be doing in conservation. But should we also be reimagining through this kind of outer loop and thinking about surveillance, experimentation, pilot studies, and thinking, are we going to have to adjust this pathway between resisting change, adapting to change, or directing change in a different direction? Okay, I think I will leave it there. I should acknowledge a lot of people who I've worked with, Brian, Judy, and Andy, who worked on the Scottish Caledonian Forest, Kai Yu, Peter Dufresne, and the co-authors on the paper of fertilisation, the long-term monitoring plots, the late Frank Perrin, who really kind of gave me all this this data from the 1950s. She has been a kind of real treasure trove. Rob and Chris, and all the people who've looked at Bill Spot Skippers, Charlotte and Robbie for that work on dormice, and all the AHPL lab, particularly Caitlin Tiago, Rob Sherman, and James Pilcher helped us with that interface, and Sasha Clark, who's an intern from his campus, who was amazing at putting this all together for the deadline. So I think I'll call it draw to a close there, and if we've got time, we'll take any questions.
Have we got any questions?
Thank you, that was really interesting. Just checking you were calling on me, not
Yes.
behind you.
Yeah, no one behind you.
The one thing I thought about was that the sort of unit to be conserved was always the species, and whether that's been discussed with heritage departments or with.
I think that's a really good point. I think that's probably partly my own bias because I've been researching species conservation. Interestingly, I guess Natural England gave us those examples. It was for this one, it was a species. They also asked us to look at the Jurassic coast, which I didn't present here, but we have done a similar process for looking at erosion on the Jurassic coast for geological. But yeah, you're absolutely right. And I think the ecosystem change, community change is as important, if not more. And they were really interesting. It's easier to think about translocating a species, for example, to direct it, moving it artificially, translocating a community. You don't know how to do that really. So yeah, I mean, there's a whole set of extra challenges there.
It's really interesting. Thanks, Jon. Thinking about adaptive management and the human role in potentially moving species. So you showed right at the beginning of your talk these maps showing that the ranges are moving further north, and we in the UK we have this big old issue of like a moat in between us and the continent, which some people think is a good thing, but but that's a barrier, right, for species moving up. And I remember back in 2022 with that big drought, it really hit me. I went up country to visit family and I'd never seen native vegetation so sad, like native English trees, English oaks, just like suffering. I remember looking at it thinking, I think we need to move seeds from somewhere warmer and drier, because just recycling the seed bank here is not going to do it for 20, not even like for now, let alone 20, 30 years.
I mean, if you look at community shifts, and people have looked at community shifts, the kind of vegetation types that are projected to be in southern England and Cornwall are much more like those in northern Spain at the moment. And interestingly, northern Spain, because it wasn't covered in ice during the last ice age, has loads of endemic species which are quite heavily at risk, quite often restricted to mountain areas, and are globally much more important than the species we have here. But that's a dilemma. Then do we start moving non-native species into British oak woodland because they're going to go extinct in Spain? And that's it. If we didn't have the Bay of Biscay, and we didn't in the last 18 months, we didn't in the Bay of Biscay, it would be an easier question because they could potentially migrate themselves. But because we're isolating, is that a decision we want to take? Meanwhile, some of the oak temperate rainforest species are probably going to be shifting up to the Atlantic coast of Norway. And it becomes more difficult when you've got a real barrier and then a sense of what is native and what is non-native.
I guess I'm a geologist, so I think on weird timescales, right? I think on like thousands of millions of years, like what is native? If you go back, a million years, what was here kind of thing? And is it more of a political kind of cultural thing?
You kind of tend to think of stuff that, post-glacial, what came over before the land, what came over before the land bridge disappeared underwater. I prefer coming from a more kind of botanical background. Like they have this thing of archaeophyte and neophyte. So if it was before 1600, it's an archaeophyte, so it's been here a long time. And partly because quite a lot of the time we don't know how long things have been here anyway. And there's been movement of a lot of stuff across with the environment, etc. So yeah, we're a nation of immigrants. As well.
Yeah, really interesting. You showed the skipper example. How does that observed change in range match the predictions in your lovely book there?
So the predictions in the lovely book for silver spot skipper says it should never be in England, and even the climate change it won't be. It's one of the species that those climate headline models do really badly. So I think we can probably do that. Probably now is data prediction have got better, and the statistical techniques have got better. We could probably get a better model, whether there's any effect. But interestingly, silver spot skipper is really interesting. So Rob Wilson has said, he sees it in the mountains just north of where he is in Madrid, and it isn't going up the mountains like you'd expect. It's just getting rarer around its longitudinal range. It's not doing well in southern Sweden, probably because the habitat is very fragmented. It's got a weird subspecies way up north in the Arctic Circle, where it just takes 2 generations instead of 1. So it manages to to deal with those shorter cooler summers just by hibernating when they're essentially hibernating as a caterpillar in its first year, after its first year's growth, and having a 2-year life cycle. So yeah, I mean, that's something that, I think we need to revisit some of these objections, actually, not in a overly critical way, because data's difficult and modelling is difficult, but actually aren't things happening the way we expected.
Just got a question. So if you look at some of the language coming out of Natural England, National Trust, particularly around sort of launch of new strategies and so forth, what you sort of see is a little bit of shift away from species, and you hear a lot of sort of language like we should be considering natural processes, whatever that actually means. And, you get a sense that sometimes there's quite a lot of loose language being thrown around. And I think that's partly as a kind of realization we've got to do things at scale, partly as a realization that we've got to embrace some of these changes. The thing that makes me nervous about it is it also does potentially reduce accountability if you've got a metric that's a lot fuzzier that you're trying to actually sort of benchmark things against to judge the success of conservation. How do you guard against that if you're also talking about the need to sort of embrace change and things like that? So it's the bit that always really worries me about.
And that's the really tricky thing about things like denotifying SSIs.
Yeah.
Because are you just allowing people to admit failure? Is it just saying, well, it doesn't matter anymore because of climate change? I think that's a really good point. And I don't have a perfect answer for it. I think that's probably something we need to think about in this kind of reimagining of change, of how we deal with change. Is how do we also recalibrating? How do we assess conservation success and failure? And what are a lot of it is defining what your goals are. And by definition, in conservation, we tend to think our goals are retaining. Our primary goal is retaining what we got, and then the secondary goal might be re-establishing things that were there in the past. Both of those goals, maybe in a lot of circumstances will become unrealistic. But how we then judge performance and have accountability, and don't allow this to be a kind of large-scale denotification of sites. I mean, one thing that's interesting, for example, for shore dock in our facility is there are still SSIs which are notified for shore dock, even though most people involved are pretty sure it's no longer there. And so there's a legal requirement for those SSIs to be managed in a way that would allow that species to thrive, even though that is largely kind of theoretical.
You wanted to comment on that, and then we'd better call it to a close because we're probably very close to 1:30 now.
Okay, thank you. I used to work with CCW, Natural Resources Wales. So I'm on an SAC with indicator species and all the very specific indicators. And I was wondering if you have any plans or if others have done similar interviews with those site managers, because that may shed light on what those people, as opposed to the strategists, what those people on the ground see and need, both at scale. I don't see a difference between, I don't see a disjunct between conservation at scale and having loose indicator. I think you can do place-based stuff at scale and you can have really specific indicators, but I think it's very important to speak to those practitioners who are doing it on the ground.
So on that piece of work for Natural England, I showed you some people. We kind of show. We also have to run. People were speaking sometimes off the record, and so we have to make sure that we're talking. Comments are only reproduced if they're happy to share that. But actually, we spoke to people working for us at City Wildlife Trust who were absolutely on their kind of cutting edge of managing sites.
Yeah.
and they had some, interesting range of views, actually.
It might be Natural England as the legislative, the guys with a requirement to deliver the legislation and, threatened species habitats, whether the language needs to move to communities, how to define that particularly, etc.
And I think hopefully this kind of approach can integrate that, and we can communicate. Is an easier way to communicate than through a policy document or an academic paper, saying, okay, this is a species, this is what the future could look like for this species, without saying, we've done this study and this is what we need to do here. This is, at least confront those people with, these are decisions that are going to have to be made. And we bring them into that.
Okay, we've reached past. It does feel like that we should have some avenue for continuing the discussions either through the Adaptive Heritage Lab or perhaps through Conscience or something. So I think there's lots of us who'd like to carry on discussing these kind of issues. But for now, I'll just say thank you very much, Jon. And if we can just give a round of applause again.